All right, hello and welcome to 6.1 Notes. Today we are talking about ratios. And your objective today is that students will use ratios to compare two quantities. So please pause the video and write your objective down. A ratio is just a comparison of two quantities by division. Now, the word quantity or quantities means the amount of stuff. So we're just comparing two amounts of things, and this happens to be using division. And there are three ways that you can write a ratio. The first way is using a fraction bar. Okay, so we put our first quantity 17. We could be talking about 17 anything really, 17 cookies. Um, and then we would put a fraction bar to 25. We could say ice cream sandwiches. Okay, but it is read as 17 to 25 using a fraction bar. Second way that you can write a ratio is to literally use the word to. So again, 17 to 25. It's still read the same way. And the third way is just to use a colon. So again, this is read as 17 to 25. So ratios are represented in all three of these ways. Fraction, the word to, or a colon. And just note that a ratio can compare a part of something to a part of something to the whole, or a whole to a part. Okay, so ratios can represent a lot of different things. Here's some vocab words, or extended, more vocab words, sorry. Equivalent ratios are just ratios that name the same comparison. Okay, they are really similar to equivalent fractions. So you can find equivalent ratios by multiplying or dividing both terms of the ratio by the same number. And I would probably write this down right underneath your definition for equivalent ratio. Okay, this is really the same thing as what we did in module 3 when we were trying to find equivalent fractions. We multiplied by the same thing or we divided by the same thing to find an equivalent fraction. You'll do the same thing for ratios. So let's take a look at our first example. We have 20 students are asked to choose their favorite music category. 8 choose pop. 7 choose hip hop. And 5 choose rock. Okay, we're going to write the ratio in all three of the forms that we talked about. So I want to know rock to hip hop. Again, a ratio being comparing quantities. So the quantity of rock, the number of students that liked rock was 5. So I'm first going to write it as a fraction. 5 on top, and then a fraction bar, and we're doing to hip hop. And hip hop was 7. There were 7 of those. So 5 to 7. The other way we can write it is 5, and then literally the word to 7. So 5 rock to 7 hip hop. And then of course the last way was using our colon. So 5 to 7. Oh, 7. Okay, so those would be the three ways to write that ratio. Now be careful, if it specifically says rock to hip hop, you must do 5 to 7. If it were reversed and it said hip hop to rock, then it would be 7 to 5. So the order matters. You need to read the original question and make sure you have it in the correct order. Okay, let's try hip hop to pop. Hip hop was 7. So again, first is my fraction. Pop was 8. Okay, so I have 8. And there is my ratio. I'm going to write that ratio as the word to and with a colon. So 8, 8. So this one is going to have the word to. This one will just have a colon. So there are the three ways to write hip hop to pop. Finally, we have rock to hip hop and hop. Pop and hip hop. Okay, so these are actually together. We need to figure out what the total number of students that like pop and hip hop together are. Well, there were 8 that liked pop, 7 that liked hip hop. So together, that was 15 students that like either or. Okay, so that was 15. And rock, of course, says just 5. Okay, so first is fraction. 5 to 15. I could do 5 and then the word 2, 15. And then, of course, I've got 5, semicolon, or sorry, colon, 15. Okay, those are the 3 ways. Now, notice this fraction right here, some of you might be noting that it can be simplified, right? 5/15, that simplifies to 1/3. So I will accept either 5/15 or 1 to 3. So for every 1 student that likes rock, there's 3 students that like pop and or hip hop. Okay, pop and hip hop. Or you could say for every 5 students that like rock, there's 15 that like pop and hip hop. They represent the same thing. They are equivalent ratios. So again, you could go 1 to 3 or 1 to 3. I will accept either one, whether you simplify or not. Okay? Here's another example. Here we have 19 students are asked to choose their favorite sport. 9 choose rock climbing, 4 choose kite surfing, and 6 choose snowboarding. Write each ratio in all 3 forms. Again, 9 for rock climbing, 4 for kite surfing, 6 for snowboarding. Okay, so snowboarding to rock climbing. Snowboarding we had 6. Rock climbing we had 9. So 6 to 9. And again, that fraction can be simplified. So if we wanted to, we could write that as 2/3. So for every 2 students that like snowboarding, there are 3 that like rock climbing. Or for every 6 that like snowboarding, there are 9 that like rock climbing. Okay, so then of course every ratio after this, 6 to 9, again, I could write that as 6 to 9, or I could write that as 2 to 3, just the simplified version, okay? Or I can write this as 6 colon 9, okay? Again, this is 2 to 3. They represent the same amount of stuff. How about kite surfing to snowboarding? Kite surfing, there were 4. And for snowboarding, there was 6. Again, this looks like a fraction that can be simplified. 4 and 6 are both divisible by 2, so that's 2 over 3, 2/3 again. Okay? Again, write your ratios in all 3 forms. So I go 4 to 6, or again, that is 2 to 3. Or I can go 4 colon 6. Okay, again, that is 2, 2, 3. All right, very good. Very last one here, rock climbing to kite surfing and snowboarding together. Okay, well, we have to figure out how many students like kite surfing and snowboarding together. So there were 4 that liked kite surfing, and there were 6 that liked snowboarding. So together, this is 10 students. Okay, and rock climbing was 9. So we're going to say 9 to 10, which cannot be simplified, or we'll say 9 to 10, or we'll say 9 to 10. So writing the ratio in all 3 formats. And then another thing you'll be expected to do is write equivalent ratios for the given ratio. So I'm given 10/12, and I want to give 3 more ratios that are equivalent to 10/12. Now, if you look back in the notes, I said you should jot down that you can find an equivalent ratio by just multiplying or dividing each quantity by the same number. So I'm going to start with maybe dividing. I could divide both 10 and 12 by 2. Okay, 10 divided by 2 is 5. 12 divided by 2 is 6. So 5 to 6 is an equivalent ratio to 10 to 12. Okay? Now that isn't my only equivalent ratio. I could find many other equivalent ones by just maybe multiplying this time by 2. So if I multiply each of them by 2, I have 20 to 24, and that is equivalent to 10 to 12. And maybe for a third equivalent ratio, I might multiply by 3. You could multiply by any number you want to, as long as you're multiplying by the same number. So this is 30 to 36. Again, another equivalent ratio. Doing the same thing in part B, writing 3 equivalent ratios. So I noticed that 4 to 7, okay? 4 and 7 are not divisible by the same number. So I can't really divide by anything. I might just have to stick to multiplying. So I'm going to start by multiplying each by 2. And that will give me 8 to 14. So this is one of my equivalent ratios. I might choose to multiply by 3 as my next option. Multiply by 3, multiply by 3. So I get 12 to 21. Okay, a lot of you would say, well, the next logical choice would be to multiply by 4. But just to show you that you can multiply by anything you want to, I'm just going to multiply by 100. Okay, so 4 times 100 is 400. 7 times 100 is 700. So 400 to 700 is the same thing as 4 to 7. Okay, so you can multiply by whatever you want to. You'll get equivalent ratios. Okay, and then your homework for 6.1 is to do the worksheet that is found on Schoology or in your packet.